is my instructor. So I'm trying to rebuild the first stage of Artemis rocket. Of the Artemis rocket. Let's go to instructor. I've did my lessons. Well, I don't gotta say that here. Just so I redo this video anyway so that I can go through the lessons. Instructor, tell me again. Not yet. I'll be back. Thank you. I'm not done. Once you go in this box, you turn into creative. Around the blue line. So. So what I did was I completely demolished the other stage and rebuilt my own other stage. Well, I'm rebuilding. Copper. I got iron, some lead, but copper. What I think should do. Okay, these are supposed to look like little grid fins or something right here, you know, connected. But then we have the grid under it. I put a grid, as I call it. It's actually just dark prismarine, but I'm calling it a grid. So yeah, I mean, I'm just practicing. I have no idea what I'm actually doing. Or maybe I do, but I don't. But, no. Open that back. This looks like a nice capsule. Yeah, think about budgeting as well. I don't know how much this capsule is actually going to cost. So, and since it's iron, it's probably going to be kind of heavy. But we need a heavier weight to push further into space. But then we have to think about the weight and the fuel. So. I don't know. We'll see how this is. I have no blueprints here. I'm just building with my mind. I think my top half of my capsule looks good. And we have the inside where, you know, people can ride. This is where the top half would go into space further. The bottom half would separate once into space a little, and then the fuel tanks would separate first a few minutes into the ride, and then the ones for this one would separate right. I'm trying to remember. I need to take notes next for my next lessons. So yeah, and this half was separated. We're going to head and down. Okay, so we need this all to connect. It's gonna be pretty heavy, I believe, anyways. I'm thinking about leaving that part hollow, and maybe I can use it like the solid fuel. I'm not sure yet, actually. The solid fuel may burn up first and then it turns to liquid, or no, it might be liquid and solid. I'm not a rocket scientist yet, but I think I know what I'm doing. I think I'm pretty close, I mean. Oops. I do need to leave one of these open so I can go up in there, I suppose. Well, no. Leave it open for now. I need to go in there in a minute. It's probably so hard to hear me. I will connect my microphone sometime next week. I have to get a few more pieces because I've already broke the ones that I had. Like that. This is looking nice. I'm proud of my build. Instructor, are you? Let's go back. I'm not done yet, though. I'll put some little coating on here. Oh, I didn't actually put a coat. I could. I have to redo it, though. Let's see. Should I? Should I? Maybe next time. We're just gonna let this right now. Because this might not be the finished build. So on my finished build, when I'm sure I'm gonna like the build, I'll then put a little coating on it. A little code. There. though. Okay. I mean, I'm liking it. I'm liking it. Kind of. My grid probably needs to be one more side. This obviously cannot be open, so what we're going to do is kind of put maybe like some solar panels. This is what it's going to look like. The room is cold. I'm going to do... Okay, so we also got to keep radiation out of the capsule, especially when it's going through the Van Allen belts. Perhaps, maybe... thinking, let's do this. Gotta close off those. We don't want nothing to come in that. The light at the end of the tunnel. Okay, let's go. Okay. Now we will have our. I say solar panel. Maybe we should do. Like web. What do you think? We'll see. This. Gotta be the solar array. Or solar panel. Then we got the web. It'll be like a kind of reflecting telescope mirror thing so that the spacecraft could. My wolf dog has something to say. Okay, so the spacecraft could have like a web type telescope thing on the front to, you know, see further into the distance, something like that. I'm trying to find the right words to say here. I'll have to come back to you on that. Anyways, but yeah. And then we got like solar. This will power it, I guess, the rest of the way because it will get solar power. So, but you don't want it. And I know web is not supposed to be facing the sun, so these. Well, I probably have to move them, but anyway, we'll fix all that. Okay, we get the idea. I'm trying to put here. We can see further into the distance. That way, if the mission needs to be aborted, the activators will activate and abort that trajectory. Something like that. Okay. Yeah, okay. I think I'm pretty proud with this build, but we need to put it where it will separate. The bottom half will have to separate. Probably right, like... here. So we'll put these. And what iron above that. Obsidian is really strong. So you just don't want your spacecraft to break apart or anything when it separates. So you want some iron, I guess. Nothing too heavy though. Probably already going over budget here. If this is going to be considered in the budget when we get back to our flight test or something like that. Okay, and we're just gonna close it off. And top half, I think it looks good. Let me go back. Oh. Trying to get, I think it looks good. Okay, let's go ask instructor if we're ready to, let's go tell her we're done for now with the first try at rebuilding a rocket top. It's done. I'm happy with the upper stage for now. Am I about to see it? That's gonna be awesome. This is awesome. Is that my build on top of the Artemis? Oh my goodness, okay. I don't know what I'm doing here, but can I just, wow. Look at that rocket. Oh my goodness. Hi, instructor. Let's have a chat. Now it's time to paint the rocket. I will hand you a spray can. You can change the color and the scale of the spray can with your inventory items. When you'll be done, come back to me to confirm your rocket, and then we will start the launch. Okay. How do I change the colors? Okay, so I got purple or yellow. Okay, that's cool. Oh my goodness. Is this real life right now? Because look at me right now. My eyes are about to tear up. What is going on here? Okay, I could have just went up that way. No, that's not the elevator. I'm really floating right now. I'm floating. Oh my gosh, look at my build on top of this rocket. Oh my goodness, I could have made the grid a little bigger on this side now. That's going to bother me, but that's okay. Look at my... Oh, wow, look at my... Okay, I'm going to come down now. Oh my goodness. Oh my gosh. Look how good it looks. Can we just... Oh my goodness. Oh my goodness. Oh my goodness. I'm just going to admire in silence for a minute. I don't even want to paint it. I like it what it is. I'm not painting my iron. I'm going back down. Wow. Ooh, wow. Check out the thrusters. Okay. Where are you, instructor? I don't want to paint it. It about fell off. That made my little heart jump a little bit. I don't want to paint it, instructor. Yes. Okay, it looks like we are go for launch. Wow, I just got somebody into orbit. Now we know we can doctor a spacecraft when we fly to the moon. Next step is building a rocket to send cargo to the moon. As part of the cargo are experiments and some instruments. These will help us prepare for sending people to land on the moon and give us important information about the landing spot. Keep in mind, launching to the moon requires a much more powerful rocket to escape Earth's gravity. If you want to retake the lessons, you can head back to the classroom. If you're ready to move on, I can take you straight to the vehicle assembly building where we'll start working on that cargo rocket. I think we should go take some more lessons. Thank you, instructor. Oh, everybody, that's such a good job here. Okay. Oh, this is amazing here. Okay. I'm going. Uh-oh. Which way? Wrong way. I'm sorry. That's embarrassing. It happens. I'm just gonna be quiet when I get out of here because this is like a library. Some important stuff going on. Okay, going back to class. Hello. I am back for another class. Oh, I can't press talk from here. I thought I'd be able to. Sorry, did not mean to jump on your desk. Okay, sorry. Welcome to the Artemis rocket build world. I'm here to tell you about the Artemis missions. NASA is going to land the first woman and person of color on the moon. As part of these missions, they will use new technologies to explore more of the moon than ever before. NASA will also work with other companies and countries to set up a permanent base on the moon. What we learn from our time on the moon will help us send astronauts to Mars for the first time. Why are we going back to the moon? Why is NASA sending people there again? Click below to find out. When you're done, move on to the next section to learn about how to build rockets. NASA is using what it has learned from exploring space for more than 50 years to explore the moon with Artemis. NASA will build a long-term presence at the moon and an outpost to orbit around the moon called Gateway. The Artemis missions will help create new jobs and industries on the moon and help people learn new skills. We will explore more of the moon than ever before with the help of other companies and countries. We will also inspire people to learn more about space. We are the Artemis generation. Now we're going to go through the door and learn about. Thank you. Lesson 2. How does the rocket work? Let's find out again, shall we? I'm back. It's always good to hear something more than once so that you can definitely take in the info. Before we start building our own rocket, let's talk about the basics. Engineers use special laws called Newton's laws to understand how forces work and make sure rockets fly properly. These laws were first written down by a scientist named Sir Isaac Newton a long time ago, but they're still very important for rocket engineers today. Do you want to know more about Newton's laws and how they help us build rockets? Let's find out. Yes, I do. Objects like to stay still or keep moving unless something else makes them change. For example, if our rocket is standing still and we don't push it, it will stay still. But if we give it a push, it will keep moving until something else makes it stop. This is called Newton's first law of motion. It's important for us to understand this when we're building and flying rockets. Did you know that how quickly an object speeds up or slows down or changes direction depends on how much mass it has and how hard it is pushed? This is called Newton's second law of motion. If we want to make a rocket go faster, we can either make it lighter or push it harder. Have you ever heard the saying, every action has an equal and opposite reaction? Well, this is a scientific idea called Newton's third law of motion. It means that when something pushes or pulls on something else, the second thing pushes or pulls back just as hard. This is how we can make things move, like rockets. A rocket engine produces thrust through the action and reaction. Action: the engine produces hot exhaust gases, which flow out of the back of the engine. Reaction: a force is produced in the opposite direction from the fuel pushing back on the rocket. When we're building and flying rockets, it's important to think about the different forces that will be acting on it. These forces can push or pull the rocket in different directions, and some forces are stronger than others. For example, the force of gravity is always pulling the rocket down towards the ground, and the rocket's engines create a force called thrust that can push the rocket up into the sky. To make sure our rocket flies the way we want it to, we need to think about how all these forces will affect it. Thrust. Thrust is the force that makes a rocket move. It's created by the rocket's engines and pushes the rocket in a certain direction. Have you ever blown up a balloon and let it go? The air rushing out of the balloon creates a force that pushes the balloon in the opposite direction. It's kind of like that with a rocket. When the rocket's engines burn fuel, it creates a force that pushes the rocket forward. This force is called thrust. Weight is the force that the Earth's gravity creates on an object. Gravity causes a mass to have weight and is what makes things fall to the ground. The Earth is big and heavy, so it has a lot of gravity. That's why everything weighs something here on Earth. But did you know that weight can be different on different planets? That's because each planet has a different amount of mass, which is how heavy it is. We want to build a rocket that can fly all the way to the moon. The moon is really far away, so we need to make sure our rocket goes fast enough to get there. We also need to make sure we have enough fuel to burn power the rocket. Fuel to burn to power the rocket. That's because the rocket needs to go fast enough to escape the Earth's gravity. Gravity is the force that makes everything fall to the ground. To break free of the Earth's gravity, we need to go fast. Can you guess how fast we need to go? After we learn more about how fast we need to go and how much fuel we need, we can start building our rocket to fly to the moon. Velocity. This means the speed of something in a certain direction. This is the short way to refer to a change in velocity. We'll be starting from 0 and accelerate to 6 miles per second, which is 9.7 kilometers per second. Going that fast, you could go from New York to San Francisco in just 8 minutes. We'll be burning our rocket fuel to achieve our delta V goal. So you see, the triangle and the V is a change in velocity. If you see a triangle and a T, that would be the change in time. You have completed my lesson. Go through the door and learn to learn rocket propulsion methods and fuels. Thank you. Hello. We now know about forces on our rocket, velocity and delta V. We have a lot of stuff to bring with us, so our rocket is going to be pretty heavy. Remember, not only do we need to bring our spaceship astronauts and enough fuel to launch our rocket, we also have to bring enough fuel to get back. A rocket with more mass will speed up more slowly, so we're going to need a lot of fuel. Humans have been experimenting with rockets for thousands of years. Early propulsion engines were developed in Greece around 400 BCE. The first true rockets were created in China about 800 years ago. Over the years, rockets have taken on many shapes. The fuel burned in these rockets can be liquid or solid. On Earth, many cars on the road are powered by engines that convert liquid fuel into energy to produce motion. You may be familiar with some forms of liquid fuel such as gasoline, kerosene, diesel, and alcohol. Our rocket will be partially powered by liquid hydrogen. With solid fuel, you don't have to fill up the tank right before launch. A solid rocket can sit for years before firing. The solid rocket fuel used in the Artemis rocket is called PBAN, polybutane acrylonitrile. Don't worry, we will make you say that 3 times fast. No worries, because I probably could not. Thank you. Let's take a closer look at the parts of the Artemis Space Launch System, SLS, rocket. Starting with the sides, we have the solid rocket boosters. The SLS has 2 solid rocket boosters that burn approximately 6 tons of solid fuel each second to help lift the enormous rocket off the launch pad and send it soaring to space. Their job is finished in just 2 minutes. Inside the large central section called the core stage are 2 liquid propellant tanks holding liquid hydrogen fuel and liquid oxygen. At the base are 4 large RS-25 rocket engines. These engines, together with the boosters, accelerate the rocket to more than 17,000 miles per hour. That's 27,359 kilometers per hour during the first 8 minutes of flight. The top of the rocket is where the Orion spacecraft is located. The long nose of the rocket contains the launch abort system that can activate on a moment's notice to pull the Orion crew to safety in an emergency during launch. The rocket is huge. You'll see for yourself in a few minutes, but not all of it will make it to the moon. Once the core stage propellant is spent, the empty tanks are just unnecessary weight, so they drop off to make the rocket lighter. This is called staging. Once launched, then fall away, splashing into the Atlantic Ocean. The core stage of the rocket, using liquid hydrogen and liquid oxygen fuel, separates about 6 minutes later, splashing into the Pacific Ocean. Excuse me. At this point, all that's left is the upper stage of the rocket called Interim Cryogenic Propulsion Stage, the ICPS, and the Orion spacecraft. About 50 minutes into the flight, the ICPS fires briefly to raise Orion's orbit. It fires again about 30 minutes later to push Orion out of Earth orbit on a trajectory toward the moon and separates from Orion. At about 2 hours into the flight, the Orion spacecraft separates and continues its journey to the moon. Thank you. Thank you. Artemis is planned to include several missions. Artemis 1 was successfully completed in December 22 with the return of the uncrewed Orion spacecraft. This launch proved the technology and paves the way for the crewed missions. Learn more about Artemis 2 and 3 below. Currently scheduled for 2024, Artemis 2 will carry a 4-member crew of astronauts farther than any humans have been into space, 4,600 miles. That's 7,402 kilometers. Beyond the far side of the moon. The 8 to 10 day mission will include testing Orion systems that enable the crew to live in space demonstrating operations needed for future missions, orbiting the moon, and collecting data before returning to Earth. Currently scheduled for 2025, Artemis 3 will be the first crewed moon landing since Apollo 17 in 1972. Astronauts aboard Orion will dock with and transfer to the Human Landing System to visit the moon's South Pole region. The crew will remain in space for about a month before returning to Earth. Now let's review some terms before you head into the vehicle assembly building. The NASA spacecraft that will carry astronauts from Earth to lunar orbit and back. This is the Orion spacecraft. Now, the SLS Space Launch System rocket is the only rocket that can send Orion astronauts and cargo to the moon on a single mission. The SLS is the most powerful rocket that's ever flown to space. This is the Gateway. It is the space station that will be orbiting the moon where astronauts will live, conduct science, and prepare for lunar surface missions on regular Artemis missions. Gateway will orbit the moon for at least 15 years, supporting long-term science investigations and human discovery on and around the moon in deep space. This is the HLS, the Human Landing System. The Starship Human Landing System provided by SpaceX is the human landing systems are the final mode of transportation that will take astronauts from lunar orbit to the surface and back to orbit. And the Artemis Base Camp. The Artemis Base Camp is a concept that includes all the elements astronauts will need to explore and conduct science on the moon. The base camp may be in one fixed location or distributed across a broader area on the lunar surface. It may include a modern surface habitat, a rover, a mobile home, and a laboratory, power generation and storage, and all the tools and equipment astronauts will need to live and work on the moon. So, we have completed the lessons. Now we're going to go through the door and head to the elevator to get started with building the rockets. We have just sent the satellite into space. Now it will be time to build the part that will be going to the moon. Yes, we have a budget. So, you can now select the rocket parts you want. Each part has a different value. After you are done, press the test button, which will run our simulation. So we need to be thinking about more fuel this time. So we'll use this. I think this, and our budget is looking good. Let's try. Excuse me. Sorry about that. I must hydrate because I have not hydrated the whole time of these lessons, and that's very important. We must hydrate with water. Test it. Did it get? How did it go? Rocket doesn't have enough thrust to lift the rocket and payload. Try increasing your rocket's thrust. Your rocket's delta V is too low. This means we will not reach our destination. Try increasing. Okay, so what we're gonna do? We need more thrust. So let's. We got a good bit of fuel, it seems, the first stage. Let's try this. Your rocket doesn't have enough fuel to reach your destination. Try increasing your rocket's fuel capacity. Your rocket's delta V is too high. Try decreasing the fuel and thrust and or increase the mass of the rocket. Let's try. It's almost enough thrust. Or budget. Your rocket's upper stage payload pass is too low. Try some upper stage higher payload pass. Okay. Let's try that. The payload is good. The fuel is just about, but the thrust is not good. Let's try that. Patience is a key here when it comes to safety and getting the rocket there on a budget. Welcome to the upper stage building hangar, where you can redesign the upper stage that way you want to. You can only build within the area marked with blue dots. When you're done, come back to me and confirm your build. Alright, well, we're going to take a break here, so come back for the next episode and see if we can get our rocket to the moon. And don't forget to like and subscribe.